Hello, my name is Sanjay Sarma, and today I'm going to talk to you about the interplay between three understudied, in my view, but important aspects of the Internet of Things: identity, ownership, and privacy. I'll start with a somewhat provocative statement, and the statement is this: the IoT world has been limited, I will make the point, to stationary objects, or mostly stationary objects. So you might say, well, why is that relevant? Well, I'll tell you in a second. But just to make the point about stationary objects, here's a picture I downloaded from an IEEE website related to IoT and blockchain. And if you look at all the icons there, they're all stationary objects, you know. It's a camera, it's a router, a microwave, a washing machine, a music system, a heating system. And as I'll argue, even for stationary systems, and I'll tell you why things that move complicate things, even for stationary systems, we actually don't have a very clear IoT paradigm when it comes to the questions of identity and privacy and so on. So let's just first look at that. Let's examine that. So even in the static world, IoT principles are not that great. You know, cybersecurity or cryptography, we have very strong foundations, but we're sort of, in my view, muddling along when it comes to cyber physical systems, and we're abusing those things, those principles, and hoping that they cover all our use cases. They don't. So here are a few examples. So obviously in IoT, we look at security as we do with computer systems, and the model is of a shadowy figure hacking and stealing your data or holding you to ransom. But actually in IoT, a whole other shebang appears, which is a denial of service attack, not of the type that you're used to, but of a physical kind. So what you can do is ping a sensor or ping a device enough times that you kill the battery. Now, who would have thought of that? But that's a cyber physical security attack that doesn't show up in the cyber world. And IoT deserves to be treated like a first-class area of research from a security perspective. And just to make the point, I call it cyber physical security. Here's another one. When we talk about privacy, most of our discussions are related to explicit data, such as, a retail company, getting your shopping patterns or something. Okay, that's good, that's important. And in IoT, that's important. But in IoT, two other forms of data become important as well that the cyber world may or may not be that aware of, the traditional security world. But IoT sort of brings it up. One is implicit data, not explicit data, but implicit data, like your voice. And just imagine if Amazon said, so-and-so's voice is really wonderful, and we want to own the DNA of the voice. And you might say, well, is that even possible? And the answer is yes. So that's what Intel did for Stephen Hawking, right? Stephen Hawking was able to speak effectively through a synthetic voice system that Intel developed for him. And it was Stephen Hawking's voice, which they extract the original from a 1986 recording, and then they use that to generate a Stephen Hawking who was able to speak through his speech synthesis system. So just imagine if someone could steal or take your voice. Do you own it, or does someone else own it? It's almost a legal question. Here's another one. Affect or emotion. So let's say you speak to your Google Voice or Apple or Siri or something. It turns out there is research to show that from the voice, one can extract, now I'm using voice here as an example, but it doesn't have to be all voice, one's emotional state, whether one's depressed. Now, the way these things are going, that means that in cyber physical systems, there are sort of, the attack surface is much wider, much bigger, and the range of issues is much more complicated. And I actually think that it is time for there to be a fundamental rethinking of the paradigms of security for cyber physical systems, rather than simply borrowing and cobbling together paradigms from cyber systems. For example, for the last two examples there, which is implicit data like your voice, or seeing if someone is depressed from their voice, one of the things we've proposed in my research group is to create something we call an emotional firewall. So the idea is when you talk to your Siri or your Alexa, you don't actually talk to, it doesn't go directly to the server. It goes through something in between that pulls out the affect, maybe even rephrases things, and in a more mechanical voice transmits stuff to the server, thereby protecting you from some of these privacy issues. So that's just one example of why, even in the static world, we haven't figured stuff out. Here's another one. When we talk about IoT, if you look at the examples I gave you, we look at things that are, as I said, static and, not that, like a thermostat. Yeah, they could make your house warm, but when you look at more heavy equipment, security, which we've talked about, intersects with humans, as with the things at home, like your Nest or your Alexa, but with the third thing, which is safety. And the intersection of these three things, security and safety particularly, make cyber-physical systems particularly vulnerable to a different class of attacks. I already gave you the example of a denial of service attack on a battery, but that could be for a sensor. And a classic example of this is something that happened last year, which was pretty terrifying, which was the Colonial Pipeline System, which supplies everything from jet fuel to diesel to heating oil to gasoline to much of the Northeast, was held to ransom in a cyber attack. And eventually, the CEO had to pay up in Bitcoin, I think $5 million. The government, I think, retrieved much of it. But that's an example of this terrifying intersection of security and safety. And so now it's not just security and human questions like privacy and affect and manipulation. It's also safety, heavy equipment. So in our research group, one of the things that George Siegel, who's now a professor at in Michigan, he and I did was we worked on something called a cognitive firewall, and think of it as a way that protects the system from attacks by leveraging the way in which the digital twin works. And I'll talk about the digital twin next, which creates another sort of paradigm that we need to explore. So now let's talk about the digital twin. If you do IoT today, you're going to do a digital twin, and the basic idea, of course, is you have the reality world and you have the digital twin world where the reality world is reflected. And that opens up new issues. So, for example, what happens if I delete my reality world? Does the twin exist? And so I say this partly as a joke. So what we need is a giant shredder in the sky, some way to take everything in the cloud and shred it. What does that mean? How can you do that? Well, if you go to Google, they tell you what data they've collected. You have to depend on them and the reputational damage they might suffer if they violated that. And they say you can delete data. But I actually feel that this deserves a lot more concerted research. Maybe we need a new social technical contract with audits and other safeguards to ensure that, in fact, our data is taken care of properly. Maybe we need other technical breakthroughs. Maybe we need a middle layer, right? That like the cognitive firewall or the emotional firewall, or maybe something with homeomorphic systems where you actually never share the data, and the data is kept in this middle layer, and the entity that's using the data comes and manipulates it and pulls it out. I mean, I'll give you an example of my Tesla or of a Tesla. I did some research to figure out all the data that Tesla gets from me, and it's pretty spectacular. Camera data, traffic, where I go, etc. Now they claim that they anonymize it, etc. But when I go to Tesla and try and delete that data, I really can't. I can get a copy of the data. So they don't have that paradigm of a giant shredder in the sky. So that's, of course I use Tesla, which is not a static example, but all these problems are sort of problems of the static IoT world. So now I'm going to talk about when things move. And I think one has to just recognize that when things move, we're entering a new realm, and I call it the Internet of moving things, and it's worth separating the two. And the reason fundamentally why moving things are different is because in the static world, we are limited. We only set things up once or twice. So for example, I set up an entire elaborate Nest system in my house 7 years ago, and I never had to touch it again. And only recently, when we sold that house, did I have to figure out how to pass on ownership to the new owners. And I figured out how to do it, but it was not trivial. I had to go and do factory research, etc., etc. But that's the only way I could transfer it. But when you go to things that are moving rapidly, the setup, which we take for granted in the static world, becomes an every day, every minute, every second thing. And we don't have good paradigms for setup and breakdowns of trust relationships, etc. And that's why movement changes everything. So I'm going to use two examples. One is of a self-driving car, and the other is of the supply chain. So let's start with the example of self-driving cars. Okay, so imagine you're in this black car and you can see the buildings there in 3D, and you're coming up to an intersection, and the car in red is coming to the same intersection. Now, there's some fair bit of work now on things like collision avoidance. There was a protocol called DSRC, Direct Short Range Communications, and the basic idea was that the red car would signal you, and you would signal the red car, and you would negotiate and say, listen, I'm closer to the intersection, please could you slow down? It turns out that was an extremely flawed approach. And the reason is this. How do you know the red car is real? What if the red car is completely fake? Maybe it's some student somewhere or some bad person who has a unit that mimics a red car and sits on a bridge on top of a highway and sends spurious signals to cars in the highway, or in this case, the black car, saying, brake, 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 brake. And you can imagine the chaos that'll cause, backups, etc. It could even be terroristic, etc., etc. So when you come to moving things, especially when there's coordination, whether it's cars on the street, heavy equipment in an open pit mine, service vehicles on the tarmac of an airport, that coordination is based on trust. Now, in streets, things like streets, which are open systems, the trust is amongst entities that may have never and will likely never meet again. So they have to establish trust with each other. It's amorphous, it's dynamic, and you have to set up and break down trust. You have to act without, and of course you could always say, let us central authority do it, right? The traffic light talks to me, the traffic light talks to the other car, it coordinates. But then the problem is you've given up privacy. So you get caught between a rock and a hard place, which is either there's a godlike entity that holds the baton and manages everything. That's also, of course, good in some respects, but brittle, because if it breaks down, then there's chaos. Or you go to a distributed system, and then you have these trust issues. So it's and what it comes down to actually at some deep level is, it's very difficult to truly authenticate your location. You can say you're somewhere, but for the other person to know you're somewhere is difficult. And the way we get around it in human driving is because we can, this car can hear the other car, and the black car can hear the other car, that you can see it, and so we have multiple modalities. So here's an example. By the way we addressed that in my lab was we did some work on something called proof of travel. The basic idea is a car builds up credibility as it travels, and so a trust score goes up, and you use that to establish greater collaborative trust. And there's a whole other thing going on there with, cars are going to depend on other cars to do something collaborative sensing. A car that's closer to the intersection will be able to peek around the corner and see if there's another car coming and tell the cars behind it it's clear. And all this requires trust, and so we propose this as one of the approaches. But that's still looking at situations where you have a single owner. So it's moving, it's much more complicated, but you have a single owner, which is, it's my car, right? Now add ownership changes, and then you enter a whole other level of complexity. So if you take a typical supply chain, right, you have a supplier a manufacturer might buy components from the supplier, like an ABS unit for a car or something, or a drive for a laptop computer. Then the manufacturer sells that to the distributor, or sometimes the distributor is just distributing, but if it's a pharmaceutical supply chain, it might be a McKesson, and then there's more of a purchase sort of relationship. Then you have the retailer, which if it's not consignment, is actually buying the stuff, and then the retailer sells it to the shopper, and the shopper truly is buying it, and the shopper then may sell it to someone else on eBay. So there's all these ownership transitions, and then it gets even more complicated because one of the things that's happening today with the circular economy is like my iPhone. I just bought the new iPhone 13. I have an old iPhone. I'm going to send it back to Apple, and they're going to refurbish it. And this means that all the things we talked about earlier become even more complicated because, well, Apple shouldn't get the data on my iPhone. But there may be some data on my iPhone that's good for everyone to have, such as, the state of the battery or something. And can they get that? It's easier for an iPhone, but if you look at some other examples, it becomes much more complicated. And the reason it's so complicated is because there's ownership changes, right? Because my Tesla, when I sell my Tesla, does the new owner get to benefit from service records? Yes, but should they know where I went? No, but should Tesla? Maybe not. So it's a very complicated set of questions that start emerging. So Chris Diorio, who, my good friend and the founder of Impinj, has this wonderful example of a to-me suitcase, and I'll explain what he talks about. He says, let's say that you purchase a to-me suitcase or a bag with an RFID tag. Well, you bought it from to-me at a store, or you bought it from some third party. I want to track it, so I need to be able to get information about where it is. There are new paradigms for doing that now, like Apple's Find My Network or the Tile Tracker, which have crowdsourcing and so on, and I can track it. But and Delta tells me where it is, or my airline might tell me where it is. They say we've loaded it, or we lost it, and it's gone to the wrong airport, but you'll get it tomorrow, and it's on its way, and so on. But then, what happens when I sell it, or what happens when it gets lost? How do people know I need to get that information? How do people know? The old-fashioned way is to look at the label where I have my contact information. But in a modern system, maybe it went from the Delta system, it ended up in the United baggage transport network. So they need to figure it out, right? And they need to tell me, or maybe it's just completely lost in an airport, and they need to find me. So how do you do that? And then if I sell it, how do I transfer ownership so that the new person has ownership of the bag, but I don't get alerts of their bag? And so there needs to be some place to reset it so that I don't keep getting updates. By the way, this happened recently with one of our devices, which I had to explicitly turn it off because I was getting alerts on someone else's use. And then that's a typo, I apologize. I don't want Delta, as I said, to tell the previous owner where my bag is, or the precious owner. And so what we need is a grand unaffiliated registry that serves individual owners. And today, all these registries really are in the hold of companies. Now, is this even feasible from a business perspective? We need to figure that out. And how does one resolve this issue? How do we collectively resolve this issue? Well, it's going to be quite complicated. We need layers of resolvers, pardon the pun, and numbers. An end owner might have a number. I'm the person who operates a device, and I need to have a means to pass ownership on and delete the information when for example, my bag leads end of life. I want the digital twin to evaporate, which comes back to the giant shredder in the sky. There may be intermediary owners. For example, I may ship my device through an intermediary to someone else, and maybe the intermediary has to have some access to the functionality of the device, but not everything, so that they can make sure it's working before they deliver it to the other party. For example, when you go through security, they make you turn your laptop on. You don't have to log in, just to show that it's not a complete fake. So they may need some access. The manufacturer will want some access at the beginning and at the end if they want to refurbish it. So what we need is layers of numbers and ways to resolve all this, and we really just don't have all these things laid out. So I'll end by saying that this is a time of humility, not hubris. So we need to really figure out where we are. To misquote Churchill, this is not the end of the beginning. This is the beginning of the beginning. And just in this presentation, I've thrown out a bunch of terms: the cognitive firewall, emotional firewalls, giant shredder in the sky, which is policy and audit, some grand layered registry system, multiple levels of ownership and numbers. And I've said that we don't have widely accepted comprehensive principles. So look, we're not there yet, and we're right in the beginning. And the Internet of Moving Things, just to sort of emphasize the point, needs a rethink, because I'm really concerned that we're going to paint ourselves into a corner and lock ourselves out of a bunch of use cases. So with that, I'll stop. Thank you very much. It's a real pleasure, and thank you, Megan, for arranging this. Take care.